Hey everybody, I almost didn't see you there. Welcome back to New Minds. I hope you guys are all doing well. It's the Steam Train again, here at 3 p.m. I am Mr. Dorian, and I hope you guys are all doing well. Today we are going to continue on our Extremes series. If this is the first episode you've caught of ours, feel free to go to newminds.tv and check out all of the other Inspirators lessons that have been before me, all of my lessons that have been before me, and all future lessons that are going to be posted there. I hope you guys are all doing well, and let's go ahead and look in our box and get started with today. Looks like I have a towel. I've got my box. I also have a rubber duck outside of the box. I'm going to move this towel to the side for now. I've got some foil, just a small piece. Some plastic wrap, also just a small piece. I've got some craft sticks, also known as popsicle sticks sometimes. A bag of coins. My scissors. These I'm going to use for demonstration, but they're just clear balls. Another piece of foil. And last but not least, 4 straws. So I have a pretty good idea of what we're going to do with this. And I think, continuing on our Extreme series, we're going to talk about big things on the water. Specifically, boats. Boats are pretty cool, and they're a really unique way of engineering. Because something huge, ginormous, is going to carry lots of heavy things, has to float on the water. And has to carry things that won't float by themselves. Now you're probably wondering how a gigantic metal ship carries itself across the water, doesn't tip, and also can carry all of these things. It's actually something called buoyancy. If you've never heard of buoyancy before, it's a mathematical formula, which means it uses math to figure it out, and it's density over volume. All you need to do is know how much stuff there is and how much space it takes up. So I'm going to use my first example. And we're actually going to use a bucket of water. Before you do any of these experiments in water at home, please ask your parents' permission first. Especially if you're doing them in something like a pool or something you can fall in, be extremely safe. Make sure a parent is always watching you. Water can be dangerous. We don't want anybody getting hurt. Now that that's out of the way, I'm going to show you my water demonstrations. So buoyancy, we just talked about, is how much stuff is in a space. You want to have less stuff and take up more space to be more buoyant. The more buoyant you are, the better you float. Let's take this ball, for example. This ball is full of air. It's not very heavy because it's full of air, and it takes up a lot of space. It's a ball. So it's actually going to float on top of the water. Let's see if you can see it. Yeah, you can see it. It's right here. It's floating on top of the water. Even if I push it under the water, it pops back up to the top because this is where it wants to be. This is how buoyancy works. It's going to set you at a certain level. I'm going to keep this towel just on the table just so I don't get anything wet and I don't get my nice tablecloth wet. So I'm going to go ahead and set this up. I should have set it up before I put the bucket down, but that's okay. I learned something. Remember, before you do anything with water, ask parents' permission first. Be very careful. You don't want to make a mess and you don't want to get hurt. You don't want to injure anything that's electronic or anything like that. Make sure you're in a safe place to do these experiments. But this is just a clear ball, and it floats because it's full of air. There's not a lot of stuff. There's nothing in here. And it takes up a big amount of space. A really good example of something that's like this in the real world is a beach ball or a ping pong ball or any ball that's full of air. It's not the same shape, but the same thing happens with rubber ducks. They are a rubber duck. They're full of air and light plastic, so they float. If you push them under, they pop back up really quickly. The same thing applies. Let's take this example and let's add it to be less buoyant. So I'm going to take this ball, I'm actually going to fill it with water, and then I'm going to close it with the water inside. Now it's full of stuff. It's full of water, so it shouldn't be very buoyant. So I'm going to take the same ball, I'm going to close it under water just so I know it's full. If I can close it. There we go. So now I have the ball. It is full of water. You can't really see a difference, but when I put it in the water, it sinks to the bottom. You can see it down here on the bottom. But if I put this empty ball, it's on top. These balls are the same size, made out of the same stuff, but there's different amount of stuff in them. This one is full of air, this one is full of water. Water obviously isn't lighter than water, so it's going to sink to the bottom. But how can we use something that has buoyancy, empty that out, and make it still float even if it's something heavy, like a boat does when it carries heavy cargo ships and packages? Let's take a quarter for an example. A quarter is going to sink when I put it in, straight to the bottom. But if I put it in this ball, which is very buoyant, their buoyancies are going to add together. And as long as it's still lighter than the... I can't open this ball. There we go. My hands are wet. As long as it's still more buoyant than the water is, I can go ahead and put it in, and it's going to float, even with the quarter inside. So now we have basically used this, and now this quarter is floating, where before it would sink to the bottom. And that's basically the principle of how boats works. We're talking about extremes, and normally when you think of an extreme boat, a lot of people think of the Titanic. The Titanic was a big passenger boat. It had a lot of people on it, but the thing is, there is a much larger boat out there, especially in modern times. This boat is huge. The amazing thing about it is it's almost 8 times the size of the Titanic. This boat is called the Seawise Giant. Boat size is measured in how many tons of water that they displace, or how many tons of water they can beat, or things they can carry. And this one is 657,000 tons displaced. That is almost 8 times, actually 12 times as much as the Titanic, which only displaced 46,000. So 657 over 46. One is a much bigger number. This boat's huge, and it's really well known for carrying lots and lots of cargo from one end to the other. And it's really cool, and boats are super awesome, so we're going to learn how to make some boats that actually float. And we're going to do some tests, because we always need to test our experiments to see how well they perform, to see how well it floats or sinks. So here are the supplies I'm going to use for my boat. Popsicle sticks, aluminum foil or plastic wrap, and straws. I'm actually going to make, I think I'm going to make 3 boats today to show you different ways you can do this experiment. All of these do reuse water, and they do use coins as a measurement. Remember, before you use water, ask parents' permissions first. I'm going to show you how to make 3 different boats, and this is going to be the first one. You notice the supplies I'm using are all light, because we want to have not a lot of mass. So straws are hollow, this plastic is very thin, and we can use it to make shapes that are all very light. So the first boat, I'm going to use bendy straws. I'm going to bend the corners and stick them into each other until I make a straw rectangle. So I took the 2 small ends and stuck them into each other. I'm going to do the same thing again. 1, 2, 3, there we go. And I'm going to do the same thing on the long ends and stick them into each other. So I have a nice rectangle that I can use to make a beautiful floating boat. It's going to be a weird shape for a little bit until you stick all the pieces together, and it'll suddenly snap into shape. So now I have a rectangle. This is going to float, but it can't hold anything. Part of my test is that this boat has to hold things to carry the weight. So I'm going to use my plastic wrap and make a platform for my quarters. So I'm just going to take it, and plastic wrap sticks to itself. So you fold it over, stick it onto itself. Remember, always ask parents' permission before you use supplies. You don't know if you're running out of something or if you need it really desperately. So you want to make sure you always ask what you use first. So now I have this boat. It's really simple, but this is going to be test 1. Boat number 2 is just a foil boat. Foil floats by itself and can keep a shape. So you basically want to make something that looks like a bucket or a pot or a circle that can hold quarters in it. So I'm going to fold mine up. Fold the edges. I'm going to fold the sides first like a U. And I want high walls so the water doesn't get in. So I'm going to fold it the other way. Fold it back. There we go. It's looking pretty good. I need my last walls. And there we go. I have a small foil boat. This is test 2. Test 3 I'm going to do with popsicle sticks because they're very wide and light and flat, so they're going to cover a big area and not be very heavy. I'm going to fold them into each other without any tape or glue. If you saw our popsicle stick lesson, you saw how I did this. I'm just going to do it really quick for demonstration. But use creativity when you're making your own boat. I want to see what kind of boats you guys come up with. So I stuck them all together like this to make a sheet. I'm going to put some on top so we have a platform for our quarters. I'm just going to lay them there. So now we have 3 boats to test the buoyancy of. I'm going to go ahead and move all my other supplies out of the way. The scissors are if you need to cut your foil or plastic wrap. I already cut mine beforehand to save some time, so I'm going to go ahead and put these away. Remember, when you're doing this, try not to get your area wet. If you have a towel under your water, that's perfect because you're going to take them out onto the towel, not onto the dry part. You want to make sure they stay dry. I'm going to move these things because they're now dry. And we're going to do a hypothesis. Hypothesis is your best scientific guess. Which one of these boats will be the most buoyant? Do you think it's boat A, the straw and plastic wrap, boat B, the foil, or boat C, the popsicle stick boat? I think boat A is going to be the best. My video editor is going to hold up a 1, 2, or 3, and she's going to guess. Which one do you think? She thinks the foil boat's going to hold the most. So we're going to find out, and we're going to do a test. We're going to do all of these tests the same way, just so we have even data. So all I'm going to do is count the coins I drop on as I set the boat. The second, after I put a quarter on, I'm going to wait a couple seconds to see if water is going to fill the boat. Because if you just put them all at once, you won't know how many it holds. So I'm putting my first boat in. It does float at first. I'm just going to go through and put these on one at a time until I know how many it carries. If I run out of coins, we're just going to call it a pass. 1, 2, 3, 4. You notice I'm not dropping them from space. I'm just setting them on gently. 5, 6, 7, 8. The cool thing to remember is that none of these quarters float by themselves. So this is all the boat's buoyancy helping the quarters float. I was on 7, 8, 9, 10, 11, 12. It's starting to shrink down a little bit. We'll see how it goes. 13, 14, 15, 16. It's getting close. 17, 18, 19, 20. Ooh, there's 2 quarters left. So it looks like we're going to do 22. If it gets 20 through, it passes the test. 21 and 22. Just so you know what a failed test looks like, I'm just going to push it a little bit. When the water starts to go over the edge of the boat, then it's going to sink because it's going to fill up with water. So even if it dips under a little bit, it's now going to sink all the way to the bottom. And the straws actually floated back up because it dumped all the quarters off. So I'm going to go ahead, I'm going to get all my quarters out. Oh, there they go. They're all in the water now. I'm going to set this on the towel so I don't get my area wet. I'm going to get all these quarters out and dry them off so we have an even testing. If we put them in there wet, they're going to be a little heavier. We're going to go ahead and test our foil boat. So the first boat was good. It held all 22. The more coins you have, the wider an area of range you can have in your test, and the more accurate it will be. I don't have that many coins. I only have these quarters I've been using over and over again. But it's what I have, so it's what I'm going to use. Do the best with what you can. That's why I showed 3 different boats, in case you're limited on supplies. Dry this off a little bit. Dry, 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 dry. If you're a real scientist, you're going to write these things down. Make sure you have written down numbers. Don't count on your memory the whole time. But so far, it looks good. Next, we have foil boat. Let's go foil boat. 1, 2, 3, 4, 5, 6, 7. Something important to notice as you're doing this test is that you need to have enough water for the boat to actually sink. If even when you push the boat all the way to the bottom, the water doesn't get in, that means you don't have deep enough water. It doesn't need to be more than 1 inch or 1.5 inches, but just enough so the boat will actually sink to the bottom so you can tell the difference. If you just have a small puddle, you won't tell when it sinks. 8, 9, 10. It's starting to go underwater a little bit, but the walls are high, so that's helping it. 11, 12, 13, 14, 15, 16, 17, 18. It's starting to tip to one side a little bit. 19. Oh no, water's getting into it. When you see water starting to rush in, it's slowly going to sink, just like that. So this one only held, well, I have 4 left, and there's 22. So I only held 18. Wait, no, 19. I have 23 quarters. I miscounted. So this one held 18, and the first one held 23. I forgot I miscounted my quarters. So that was a good test. We didn't push too many on it. It was already starting to fill up with water. I noticed it, and I saw it start to sink. Why do you think the foil performed a little worse than the first boat? Maybe because it's smaller, so it's more dense. Maybe because this one has lighter materials. Foil's a metal, so it might be pretty heavy already. You never know until you try all the experiments and you figure out which one's going to be best, which one's going to be worse. So try it out for yourself, or maybe you have your own design for some sort of super boat. Maybe you have recycling that you've been meaning to use, like plastic bottles. Those would make really good buoyant materials. Anything that can hold air in it is going to be perfect for this experiment. The last thing I have is this wooden boat. Neither one of us picked this one. We'll see if we're proven wrong by these popsicle sticks. Let's find out. I think my bucket's big enough to hold this. Yes, it is. So we have our raft. It's floating elegantly on top. You probably won't be able to see it until it starts to sink because it's level with you guys and it's very thin. But I'll try and stack the quarters in the tower so you can see how tall they are. 1, 2, 3, 4. It's not budging yet. 5, 6, 7, 8. One side's starting to get a little wet. 9. And there it goes. Our boat has fallen apart. It didn't just sink. Some of it floated. There's one. Oh, there he goes. There was one survivor on a little thing like this. It's funny to see all these George Washingtons floating to the bottom with all these quarters. And that is buoyancy. It's a test and a measurement of how well things float or how well things sink. If something is really unbuoyant, like lead, no matter how big you stretch it out, it's always going to sink. You can take the same object that will float and make it sink. For example, this foil boat still floats because now there's no water in it. But if I crumple it up into a foil ball, it doesn't have the same volume anymore. It doesn't take up the same amount of space. So it should actually sink. It doesn't actually sink yet. You would need a bigger ball. But if you had a big enough ball of foil, it would actually sink to the bottom of the water. It's so small that it's still very light. That is all I have for you guys today. And thank you for tuning in with Real Inspired Learning with New Minds. Keep practicing your passions until they become your talents. Maybe it's boat building. Maybe you just really love boats and buoyancy. Keep pursuing that until it's something you're really good at. Thank you guys for watching. I'm Mr. Dorian. Don't forget to check out New Minds TV, and I hope you guys have an amazing rest of your day.